Have you ever wondered what powers apps like YouTube, Instagram, Facebook, Netflix, and ChatGPT? The answer is Python, one of the world's most popular programming languages. Python helps developers build websites, AI systems, automation tools, games, and mobile app backends. When you scroll Instagram, Python can be used for data processing, recommendation systems, and server-side features. Streaming platforms use Python for analytics, automation, and parts of their recommendation systems. Many AI applications are built using Python because it has powerful AI and machine learning libraries. When you watch a YouTube video, Python can help process data, manage recommendations, and support back-end services. Python is used in AI, web development, data science, automation, cybersecurity, and much more. The best part? Python is beginner-friendly and easy to read.
Welcome to Chapter 2. Today, we'll install Python on your Android phone so we can start building our projects. Welcome to Chapter 2. Today, we'll install Python on your Android phone so we can start building our projects.
Now, let's open the Google Play Store. Type Python in the search bar. Select PyDroid 3 from the results. Click Install to begin. And that's it. Our mobile Python environment is ready. In the next chapter, Chapter 3, we will learn how to store YouTube video information using variables. Every YouTube video has information like a title, views, and channel name. Python stores this information using variables. Think of them as digital labels for your data. A variable is a named container that stores information. This variable stores the title of the video. A variable is a named containers. Let's write our first real-world Python program. This variable stores the number of views. This variable stores the number of views. This variable stores the number of likes. This variable stores the number of views. This variable stores the channel's name. Together, these variables describe one YouTube video. Let's write our first real-world Python program.
Let's break down this first line of code. Here, variable. Think of it as a labeled box. We use the equal sign to store this piece of text inside it. Now you can use that label anytime. Let's explain the next lines. Channel name stores Code Academy. Views and likes store numbers. Variables hold your data. Ready for more code? Now, let's use the print function. It outputs information to the screen. We can print text and variables together. And here is your output. Here is the output of your program. It printed the header text first. Then, it displays the video title and channel, followed by the exact views and likes.
Every Instagram profile contains different types of information. Python stores this information using different data types. Different types of information. Data types tell Python what kind of information we are storing. Profile contains text information is called a string. For example, a username or bio. Let us examine this Python code. Text in quotes is a string. These strings are stored in variables. Quotes define the string. Every Instagram profile contains numbers are stored as integers. For example, followers, and post counts. Let us examine this Python code. Followers are whole numbers, so integers. Post counts are also integers. Integers have no decimals. Every Instagram profile can true or false values are called Boolean data types. Instagram uses similar concepts for verification status. Look at this Python program. The variable is verified. It is set to true. This is a Boolean value. Look at this Python program. A real application combines many data types to create a complete user profile.
Look at this Python program. The variable is verified. It is set to true. This is a Boolean value. Look at this Python program. Text in Python is stored as a string. Here are two examples of string variables. Look at this Python program. Whole numbers like followers and posts are integers. Numbers with decimals like the rating are floats.
When a math function displays your data on screen, we can print variables like name, followers, and posts. Even verification and rating appear instantly. When a math function displays your data on screen, we created an Instagram-style profile using different Python data types. Even verification. These are the basic data types you will use in almost every Python application. In the next chapter, we'll learn how apps take information from users using Python input.
Whenever you log into Facebook, Instagram, or any app, the app takes information from you. In Python, we use input to collect information from users. User input means allowing the user to enter data while the program is running. Many applications ask users to enter information, like their name, email, or password. In Python, we use the input function to collect information from the user. When the user enters a value, Python stores it inside a variable. Now let's create a simple Facebook-style login system. These lines set the correct username and password. They are stored in variables for later use. The input function pauses the program and prompts the user to type text. Whatever the user types for the username is stored inside the username variable. The password is also stored. The print function takes the stored values from the variables and displays them back on the screen to confirm what the user entered. When you run the program, it executes like this. Enter the username and password details. The program then displays the stored values back to confirm what you have just entered. First, we define the correct credentials. These are stored in variables for verification. We assign them predefined string values. The input function prompts the user to enter their credentials. It stores their typed text into the variables. The if statement uses the AND operator to check both conditions simultaneously. If both match, it executes print successful. Otherwise, the program prints invalid login. When you execute the script, the program starts. It prompts the user for authentication. Both values must perfectly match to proceed. Only then the con's successful. This confirms successful authentication. Almost every app you use asks for information. Whether you're searching on YouTube, logging into Instagram, entering your address in a food delivery app, or typing details and interact with users. In this lesson, students learn the input function and how to store user data in variables. They also master comparing user information to create a simple, working login system. In this lesson, students learn the Next, we'll learn how apps make decisions using Python conditions.
Let's analyze this simple Python code. It checks if the followers count is 10,000 or more. Since it's true, it prints "you are a creator." Otherwise, it would have suggested to keep growing. Every app makes decisions. If your password is correct, you enter the account. If it is wrong, you get an error message. In Python, we use if-else statements to make decisions.
The if statement checks a condition. If the condition is true, the code runs. If the condition is false, the else block runs. A variable is created. A variable is created. This represents the stored password. Captured and stored in the password variable. Captured and stored in the password variable.
The else block runs when the if condition is false.
The stored password is compared to the input you enter. If they match, login is successful. Otherwise, you get an error message. The stored password is compared to the input you enter. If they match, login is successful. Otherwise, you get an error message.
Online shopping apps use if-else statements to make decisions. If a product is available, the order is confirmed. Otherwise, the app informs the customer that the item is out of stock. Let's analyze this simple Python code. It checks if the followers count is 10,000 or more. Since it's true, it prints "you are a creator." Otherwise, it would have suggested to keep growing. In this chapter, you learned about program conditions and the if statement. You also mastered the else statement and comparison operators. Now you know how apps make smart decisions. In this chapter, you learned about program conditions and the if statement. You also mastered the else statement and comparison operators. Now you know how apps make smart decisions. In this chapter, you learned about program conditions and the if statements, the technology behind repeating actions in apps operators. Now you know how apps make steps.
When you scroll YouTube Shorts, new videos keep loading again and again. In programming, we use loops to repeat tasks. A loop allows a program to execute the same instructions multiple times. Python has different types of loops. The most common ones are for loops and while loops.
This loop runs 5 times and displays each video number.
Let's create a list for our simulator. We define it using square brackets. This list holds multiple items. Each item is a string. Let's see it in action. Now let's look at the loop statement. This line tells Python to look inside the list. The variable video grabs each item one by one. This continues for all items in the list. Let's see the full execution. Python executes this print statement. It combines playing with the video title. This repeats for every item. This process repeats until the loop finishes. In the real world, this is a game changer. Instead of writing thousands of lines, this 2-line loop handles everything. This is how apps like loops power your everyday apps. A while loop continues running until a condition becomes false. Loops are used in apps for repeated tasks like loading feeds, processing data, showing recommendations, and handling thousands of users. Let's review what we've learned: why loops are essential, how both for and while loops work, how to repeat, and how to build your very own simple feed system.
Every day we send messages on WhatsApp. In Python, text data is called a string. Strings are used to store words, sentences, usernames, and messages. Strings are used to store. We can store a message inside a variable and display it using print. Python can combine strings using concatenation. Apps combine different pieces of text to create complete messages. This program creates a WhatsApp-style message using strings. Apps combine different pieces of text to create. This program creates a WhatsApp-style message using strings. Apps combine different pieces of text to create. Python can change text format using built-in string functions. Apps combine different pieces of text to create. Apps use text searching features to find messages and information. Apps combine different pieces of text. Strings are everywhere. Messages, captions, comments, usernames, and search systems. Apps combine different pieces of text. Strings are everywhere. Great job! You have learned the basics of strings. Next, we will explore Python lists. A playlist contains many songs. Instead of creating separate variables for every song, Python uses a list to store multiple values together. A list is a collection that stores multiple items in a single variable. Python uses a list to store multiple values. A list. Here we created a list of songs, shape variable, single variable. Python uses a list to store multiple values. A list. Here each item in a list of songs, shape variable, single variable. Python starts counting from to store multiple values. A list. Here each item in a list of songs, shape variable, single variable. Python starts counting from to store multiple values. A list. Here each item in a list of songs, shape variable, single variable. Python starts counting from to store multiple values. A list. Here each item in a list of songs, shape variable, single variable. Python starts counting from to store multiple values. A list. Here each item in a list of songs, shape variable, single variable. Python starts counting from to store multiple values. We can also remove items from a list. Lists are used everywhere: playlists, followers, products, comments, and many other app features. Next, information like locations. Welcome to the next chapter on tuples. Unlike lists, tuples store information that cannot be changed, like GPS coordinates. We define them using parentheses, square brackets. Let's create another tuple to represent coordinates. Notice how we use round brackets this time. This confirms that the data is now fixed and secure. Well done, you have mastered the basics of tuples. Every location has coordinates like latitude and longitude. Python stores fixed data like this using tuples. Just like lists, tuples use indexes to access values. Lists are mutable, meaning they can change. But tuples are immutable and cannot be modified. This guarantees that your fixed data remains safe and constant. Let's create a program to store location data. We store the place name and its fixed coordinates. Nested tuples can store multiple records. Tuples are ideal for storing multi-fixed records. They are used in maps, weather, and banking. Remember, lists are mutable and can be changed, but tuples are immutable and protect your data. Unlike lists, tuples cannot be modified. Trying to change a value will result in a type error. This makes them perfect for securing important fixed information. Let's apply this in a mini project. We create a simple Google Maps location system. This program stores a place and its coordinates. When we run this code, we get the formatted output. The terminal displays the place, and its coordinates. Tuples can store multiple fixed records, like coordinates for several cities. We can group these together in a nested tuple. Tuples are useful in real-world apps like maps and GPS. They also store data in weather and banking systems. They are ideal for any fixed data records. In summary, lists are flexible and mutable, but tuples are immutable and protect fixed data. Now you know what tuples are and how to use them. Next, we will learn how apps store information using dictionaries.